Right, welcome back. Let's just quickly wrap it up around the formation of images. Here, you're told, when we're looking at image formation here, if an object is beyond 2f, now what do we mean by beyond 2f? Here you would have f, you would have 2f, for example, and beyond 2f somewhere there. If the object is there, you would have a real image inverted and reduced, in other words, smaller than the object. If the object is at 2f, you will have real image inverted, and it shall be, the image will be of the same size as the object. Next, object between 2f and f, which is actually the case that we have here, between 2f and f object there, what you would have is that you would have a real image inverted and enlarged. The size of the image in this case becomes bigger than the size of the object. If you have your object at f, the focal point, okay, you would have no image being formed. And if you have your object beyond f, okay, very close to the lens, you will have a virtual upright image which is enlarged, forming. Okay, so that's what you would have in these different cases about object formation. Now quickly, let's then move on to Huygens principle. Okay, and this applies mainly at grade 12 level. Huygens principle is around the issue of diffraction, which is what? The bending of waves around the edges of an obstacle. That is what diffraction is all about. And the speed of the waves, now this is what we need to understand. The speed of a wave does not change when the wave passes through an obstacle or bend around the edges of obstacles. So the speed of the wave stays the same, does not change during diffraction. Next, if these waves are going through a slit or an opening, waves will experience two edges of obstacle. So if this is the opening, there is that edge and this edge. They experience two edges there, and they will be bending around the two edges. And as the bending happens, then interference obviously is going to take place. We're gonna have interference, and we know with interference we're either going to have constructive interference or destructive interference. Okay, now what does Huygens principle say? Huygens principle says each point on a wave front can be regarded as a source of secondary wavelets that spread out in a forward direction. Spread out in a forward direction at the speed of the wave, forming new wave fronts being a tangent to all the wavelets. Okay, so what Huygens is saying here, if we have a wave, those are wave fronts here, waves coming in that direction as shown, gets in there, the edges there of the obstacle, they begin to bend around the edges. As they do that, every point on this wave front here can be regarded as a source of secondary wavelets, and these secondary wavelets obviously will be forming in the forward direction like that, moving in the speed of the wave, and as they do that, interference takes place, and as we know it, either destructive or constructive interference. Okay, now if we've got a single slit like we were explaining, it is very important to understand that with a single slit, that's when you have the broad central bright band, and this is when we're talking about light waves. So if it is light passing through a slit, you will have a broad central bright band. The other bands following that one becomes what we call the first minima, the second minima. The first minima should be greater in broadness to the second minima in that way. Okay, and the one up here, we will call it minima plus 1. This one will be minima plus 2. down here, because it's below, we'll call this minima minus 1. This one will be minima minus 2 in that way. Okay? Now, when we're talking about single slit diffraction, key important points, you have got one very thick central bright band. Next, you will have the first, the second, the third minimas. You use small letter m to represent them. Okay? And you will have minima 1, minima 2, minima 3, and so on. You can have minima 4s, minima 5s, and whatever. Below it, we will call, or on the left side of it, if it's just horizontal, we'll call the first minima minus 1, minus 2, minus 3. These values here do not have the mathematical meaning, but only tells us the position where they are. Okay, and when we are to find this diffraction, we make use of this formula here. This is the size of the diffraction, sine theta. It is given by m, which is the number where that minima is, times the wavelength divided by the size of the slit. And we'll pick it from here when we come back. Let's see each other in the next section.